Hello, good morning, ladies and gentlemen. Welcome to our digital forum entitled Gos-Lift Field Operation and Optimization, organized by Invigor Energy's New Berhad. As we are seeing more people joining our discussion, let's take a few more minutes for everyone to settle down. We'll come back shortly. Hello, good morning again, and welcome to our digital forum. On behalf of Invigor Energy team, I would like to extend a very warm welcome to all of you. We're delighted to have our friends joining us today, not only locally from Malaysia, but also from neighboring countries like Indonesia, Singapore, Australia, and we understand that some are also from the US. Thank you so much. It must be quite challenging for you considering the time frame, so we appreciate your attendance. Hi, my name is Fazlin, and I'll be the moderator for today's forum. Before we start, let me give a short introduction of Invigor Energy. Invigor Energy was established in 2015, where we deliver integrated services, including consultancy, technology, and learning to help our clients' differing needs in the oil and gas industries. Our main expertise is in petroleum engineering, reservoir engineering, production technology, and other subsurface disciplines. We've worked with various clients locally and also internationally. As part of our learning product offerings, we have conducted quite a number of industrial training courses with our experienced instructor and our very experienced guest trainers. Some of the training that we've conducted are practical course for Gos-Lift field operation and optimization and oil field integrated production modeling. We also plan to have a new one coming out, which is an introduction to production technology, which will be happening very soon. So please visit our website at www.invigorenergy.com if you would like to know more about our training courses. We will also provide more information on this towards the end of our forum, so please stay tuned. For your information, we are also a certified member of CPD UK. Two of the courses that we mentioned, which is the Gos-Lift field operation and optimization, and also the integrated production modeling, are both certified with CPD UK. And we are also looking at adding more accreditation with CPD UK on our additional training courses. So this is actually our commitment to create and meet higher quality training to our clients. Just to share a bit of a good news as well, we've recently received an award, which is called the SME 100 Fast Moving Company Awards. This is actually a premier regional awards for small and medium-sized enterprise as an assurance that to our customers, investors and partners, that we have achieved a level of success that is quite beyond the ordinary. Okay, that's the brief introduction on Invigor Energy. Like I said, please visit our website to know more about our services. Before we move on to the discussion, just a reminder to take note of the forum house rules that we are now displaying on the chat box. You can send any questions or any concerns that you have to the panelists through the Q&A and also the chat box tab at the bottom of your screen. Our team will be monitoring the tabs and will take note of the happenings and will address any questions that you have during our Q&A. Okay, so let me introduce the panelists for today's forum. The first panelist is Thierry Wee. Thierry is a founder and managing director of Invigor Energy with 18 years of industry experience. His subject matter expert includes Gos-Lift optimization, integrated production modeling, and well performance modeling. And joining us from all the way from Australia, actually, is David Lee. David is a gas lift consultant who is now semi-retired with more than 50 years of industry experience. He has been working with ESSO in Australia, Malaysia, PNG, Europe, and USA. He also has worked for 14 years with Shell as gas lift expert in the global artificial lift team. Hello, David and Thierry. Welcome to the session. Let me just unmute you so that we can start the ball rolling with our discussion. Over to you now, Thierry, to start the forum.
All right. Okay. Thank you. Thank you, Fazlin. And thank you, everyone. Very good morning to all of you in Malaysia, in Asia Pacific, and good afternoons and good evening to those of you in coming from a different time zone. So I'm going to take over the presentation from here. And after my presentation, we'll followed by a presentation by David. I'm going to start. Okay. All right. Okay, so again, good morning. I'm going to talk about gas lift designs, and I'm going to talk about approximately about 15 to 20 minutes before I hand over the floor to David. So before we do gas lift design, I think it's very important that we ask just exactly, what are we trying to achieve with the gas lift designs? And you find that there are many reasons to do gas lift designs, and it tends to fall under these 5 categories. All right. Okay. So animation is coming on now. So one of the most obvious reasons for gas lift design, especially for a new well, is to unload a new well, to kick off the new well, to get rid of the completion brine inside the well, and to basically try to bring the well back to life, back to productions. So that is the very obvious reason. And the next category is we are looking at to optimize gas lift performance. So what do we mean by that? So sometimes you might have well that is injecting too much gas or too little gas, and through a good gas lift design, we are trying to basically achieve efficiency. And what do we mean by that is we are trying to lift the maximum amount of oil or liquids by using the least amount of gas. So that's optimizations. And the next thing is would be we're trying to improve the gas lift performance. So typically this will just be things like we're trying to achieve a deeper injection, because when you inject the gas at a deeper depth, you can lift more fluids, you can create a better drawdowns. And also if you can inject more gas, that will help lighting the gas columns, the liquid column inside the tubing much better. And lastly, also, if you have well that is having multi-pointing issues. So what do we mean by multi-pointing is when we have multiple unloading valve inside the well that is injecting. So sometimes, depending on the situation, that could not be desirable. The next category is we could be trying to elevate the well stability issues. In some cases, when you have well that is not having enough gas, the well could be slugging. And by injecting more gas, we could actually help the well to become more stable. So that is one of the method that we can use the gas lift to optimize the wells. And the other one is in the case of a dual string, where you have the long string and short string, they are interfering with each other's, and both string is stealing gas from each other, and that is what we call gas robbing. By doing a new designs, trying to elevate the problems, that will solve the problems. So that could be another objective. And last but not least, we are trying to extend the life of the wells. And you can see that when you just have a well that is flowing naturally without gas lift, the well could only flow to a certain period of times. And very often you see that when we start injecting gas lift, the well can stay on production for a much longer period of time. And the reason of that is because by using gas lift, we are able to reduce the abandonment pressures of the well. And by doing so, we can make the well goes a lot much longer. And that's really all about maximizing value from the wells. And this is what we call, value, creating value and catching value from the wells. I'm going to move on to the next slide. So we have quite a few people joining us today. So I can see that there's quite a few that is quite new to Gos-Lift. So I'm just gonna have a few slides talking about exactly what Gos-Lift actually do in the wells. In the next few slides, we're gonna show you how Gos-Lift is used to unload a well. So over here, we have the pictures of a well completions, and you can see that the well has got 1, 2, 3, 4, 5 gas mandrels, and this will be fitted with an unloading valve. And to the right of the pictures, we have what we call a pressure traverse plot. It's really a plot of pressure with depth, and very often you see that what is in the plot is casing injection pressure line, so which is the lines here, and you have the static gradient line, which is which simulate the water columns inside the wells, and you also have the tubing pressure for flowing conditions. Now you also see that there's a little zigzag profile in the plot, and that is really the unloading pressures when we unloading the well from mandrel to mandrels. And toward the far right bottom, this is where we have the reservoir pressures, which is at the end of the hydrostatic pressures. So now, as we commence the gas injection to unload the wells, we basically injecting gas into the casings, and the casing pressure will eventually build up to certain pressures. Now, as we continue the injections, what will happen is that they will reach a point that the unloading valve will start to open. In this example, the Gos-Lift valve that we have used in this example is actually IPO valve. So what it means is that the valve will actually open depending on the pressures inside the casing. So as we pressure out the casing, as we inject gas, the valve will start open. So you can see that in this plot, we have all the valve opens, but not all the valve is able to start injecting gas because the pressure inside the casing will have to overcome the tubing pressure before you can have injections across the Gos-Lift valve. So when that happens, this is when you have the Gos-Lift injecting into the tubing, and the fluid inside the tubing are able to be lifted out of the tubing to the surface. So this is sometimes what we call U-tubing effect. So you have the gas coming from the casing, pushing the liquid out of the tubing. So in this example, in these pictures, you can see that we are starting to inject at the first Gos-Lift valve. So as we continue,
just on that, Terry,
yes,
a note is that all the valves are open. You're pushing the liquid in the casing down and through each of the valves and up the tubing. So at this point, all of the valves are open. The valve that is passing gas is passing gas. The others are passing liquid.
yeah.
And this is a critical phase in unloading that you could damage any lower valves.
Exactly, that's a very good point. So very often we have to bear that in mind when we actually unload the well, how fast we're pressuring out the casing, and whether the fluid would actually cut the Gos-Lift valve. So these are all very intricate considerations when we design a well unloading. Now, as we continue the process, as David mentions, we are pushing the liquid down the casing. You see that now the gas has reached the second mandrel, and because of the pressure now is high enough to start injecting. So you see that the fluids are able to be U-tubed out at this interval, and gas is starting to percolate from the Gos-Lift valve up the tubings. So this is how the tubings column inside getting aerated by the gas being injected from the casing. Now, as this process continues, the lifting point is being transferred from the second mandrel to the third mandrel to the unloading valve, and you can see that the blue line, which is the tubing pressure, will get lightened, and the process will then continues. Now, I would like to draw your attention to the bottom of the blue line, which is the flowing pressures. Now you can see that the blue line actually had come a long way from the original position. So imagine the original position was about 3600 psi, and now you can see that the the bottoms of the blue line is about 1300 psi. So you can see that that difference is what we call the drawdowns. Sorry, just having some issue with the slides. It's moving on its own. So as I was saying, so you can see that the bottom of the valve pressure has lower, and that difference between the original pressure is what we call a drawdowns. And that is exactly the reason why we have fluid coming from the reservoir being sucked into the tubing and going up the tubing. And this is actually one of the objectives of unloading, is to create that drawdown so you can start encourage the fluid from the reservoir going into the well and up the tubing. So if you like, that is in some way, that is the ultimate objective of gas lift unloading. So that is gas lift unloading. So I'm going to go over to some other considerations. Of course, before we start the gas lift design, we have to be bear in mind, what are the gas lift equipment that are installed in the well. So then we know, what are we dealing with. So now it's very important for a gas lift completion to be completed with gas lift mandrel, or sometimes also called a side pocket mandrel. What does the gas lift mandrel actually allow is it allows the gas lift valve to be installed in the mandrel, so you can then either plug off the mandrels, or have unloading valve, or have orifice valve. That would help with the that give us a multitudes of versatility for gas lift designs. Of course, if we have more mandrel, that give us the better envelope for designing. And very often you see that when we have certain well that is installed with very little mandrels, that really restrict our the amount of extent we can achieve with the gas lift designs. The size of the mandrel is depending on the size of the tubing. So obviously, if the casing is bigger, tubing is bigger, it tends to equip with bigger mandrels. So mandrel is a key element for gas lift completions. Now I'm going to go over to a gas lift valve. So there are predominantly three types of gas lift valve. So the first one would be a dummy valve. So essentially is to plug off the gas lift mandrel that we don't need to use. So depending on the gas lift design, there will be certain instances that we need to use the mandrel at different depths. And very often the design could be that we only use a number of the mandrels, and certain mandrel will not be used. And when that happens, we need the dummy valve to actually install to isolate the mandrels. The second valve would be orifice valve, which is very common. And this is normally what we are trying to achieve the design with a continuous injection at the orifice valve. The next valve would be unloading valve. So this valve tends to be used during unloading. So as we mentioned before, in the previous example, we have shown you how the unloading valve actually is very instrumental for transferring of the injection from the shallow points to the deepest points. So unloading valve is really the equipment for doing that. And very often you see that a gas lift design would have the orifice valve at the deepest mandrel, because that is normally what we want to have the continuous injections at the deepest depth. So how does a gas lift valve work? So a gas lift valve is essentially like a pressure regulator. Very often is it preset with certain pressure limits, and depending on the pressures that is set, normally it's set in the labs. As long as the pressure is reached, the valve will start opens. Gas lift valve, unloading valve, they are essentially of two types. One is what we call IPO valve. IPO valve is basically injection pressure operated valve, and it responds to casing pressure. So for this kind of valve, you need casing pressure to actually open the valve. The other type is actually what we call a production pressure operated valve, meaning to say it's actually operated based on tubing pressures. So this one is quite different from IPO in the sense that it actually needs the tubing pressure to open the valve. Okay, so here we have the dummy valve, and I just want to show you the picture of the dummy valve. You can see that where you have the black rings, and that is actually the elastomer, and that is the packing elements. And this is really what actually helped the dummy valve to be sitting in the side pocket mandrels and actually and form that seal to isolate the casing from the tubing. So I talked about PPO valve being unloading valve that is opened by tubing pressures, and very often you have people asking, why do we need a PPO valve? You find that PPO valves tend to be less common because for one thing, they are actually quite difficult to design in the sense that you actually require another level of thoughts when it comes to gas design for PPO valve. But it does have its uses. For example, in the case of dual string valve, when we are trying to elevate the interaction between the long string and the short strings. So that would be an instance where we actually have to use PPO valve. The next category would be the IPO valve. So IPO valve tends to be more commonly used, and purely because it's very easy to design and it responds to the casing pressures, and you could actually it's quite easy to regulate the casing pressure. So a lot of the operator find that IPO valve is very easy to use. But however, IPO valve would be not the ideal choice for a dual string valve, just purely because when you have the dual string sharing the same pressures, and very often it's quite difficult to have one string operate in a different way when they all have the same, they are subjected to the effect of the casing pressures. An orifice valve essentially is like a door that is always opened, and as long as the casing pressure is high enough to overcome the tubing pressure, you will have gas being injected from the casing to the tubings. The orifice valve is also equipped with a back check, and that is to prevent the reverse flow from the tubing into the casing. And why do we have that? The reason is because of well integrity. Very often you find that the rest of the fluid could be corrosive, and you don't exactly want the fluid to be flowing backward to the casings. And the casing is a very important part of equipment because it forms the first barrier for the well integrity management. So we really try to protect the casings, and that's the reason why we have the back check installed in the orifice valve. So we talk about the equipment. So now I'm gonna quickly talk about what are the other considerations when we're doing a gas lift design. When we start doing a design, very often we have to understand, what exactly we're trying to achieve, as I mentioned before, and very often it's good to start with an end in mind. And very often, so we rely on what we call a performance curve, which is the graph that I'm showing here, which is a graph of liquid rates versus a gas rate. So the gas rate could be either a total gas rate or a gas lift rate. When the gas rate is gas lift rate, we call this a gas lift performance curve. And how do we use this curve? From here, you could see that, for example, when the well is having not enough gas from the reservoir, the well could be slugging. And this is when we have to introduce additional gas to basically improve the performance. And as we do so, we will reach an optimum point when where we achieve the highest efficiency, where we are injecting the right amount of gas to lift the highest amount of liquid. Now, as we inject more gas, you start seeing that there would be other undesirable effects start having effects. For example, when we are injecting more gas than we need, the gas itself will lead to more friction inside the tubing, and that friction, so additional pressure drop, will start backing out production from the reservoir. And this is how you can see that in the graph. As we increase the amount of gas inside the tubing, we actually have a falling liquid rate. So it's very important when we start doing the gas design, we have to know what is the boundary, or what is the targets we are trying to design. the well for. In this case, we'll be looking at, what would be the target design liquid rate for the wells, and what would be the amount of gas we'll be using to achieve that. Previously, I talked about IPO and PPO valve, and you can see that I have got the gas lift designs for PPO and IPO valve on side by side. You could see that visually, the envelope for design is quite different. For example, when you have more casing pressures, available casing pressure, you see that there's more room to play with the IPO valve. When you have a less amount of injection pressures, a PPO valve sometimes would help in that scenario, because you could still achieve lifting to a deeper depth with a lower casing pressures. So it all depends on what you have at hand, what is the boundary, and it's very important to know that before we do gas lift designs, because that will really determines our choice of what kind of valve we'll be using, and just what kind of playing rooms we have with the designs. Now, if you are very experienced with doing gas lift designs, for example, like David Lee or even Jim Ho in the audience, you find that you probably can do most of the design, by hands, on a graph, on a piece of papers, or even doing that, in your own head, just by thinking about it. But some of us, we find that we could also do gas design using commercial software packages. Over here, I'm showing you a software Prosper. You could also use WinGlue for gas lift designs. And what the software would actually need is some of the boundary conditions. So for example, we need to know, we need to tell the software what is the back pressures for the well to unload the fluid to the surface systems. We also need to tell the software what are the available injection pressures in the system that is available for use for unloading and kickoff. We also need to tell the software what are the available gas lift valve that is available for achieving the gas lift designs, and what are the sizes, and what would be the opening and closing pressures of the unloading valve. And as I mentioned, we have to also tell the software, what would be the design rate for the gas lift designs. So there are quite a few considerations that you can see that when we're doing a gas lift design, even with the help of software. And sometimes it can be daunting, and this is actually when experience really helps. So I hope I have able to instill some thought in you when it comes to gas lift designs. And due to the nature of these sessions, we are not able to go into great depth in these sessions. But I hope that the material is enough to provide some thoughts and for you to ask some very good questions later on.